In session 67 here, we're now going to go and advance a little bit more into factoring polynomials, especially here second degree polynomials. But before we do that, it's very important that you just remember the process of factoring. We're using here our distributive property. We don't have any second degree polynomials yet. We simply have a x plus 4 here being multiplied by an x plus 9. But in order to find out what this answer is, we have to use our distributive property. The distributive property is at the core of factoring polynomials and many such type factorings. The distributive property is crucial. So I just want to spend a little bit of time here demonstrating this once again, because if you can keep this in mind as you go backwards, which we'll take a look at shortly, it will help you as you factor these different types of polynomials. First of all, what does your distributive property say? It says that you take each term inside one particular phrase, algebraic phrase, that's being multiplied by another phrase. You take each term here and multiply it by each of the terms in the other phrase. So if we start here with our x plus 4 times x plus 9. Our first term here is x. What we do is we take this x and we multiply it by our first term here in our second phrase. What is x times x? Well, it's x squared. The next thing we do is we take our same first one and now we multiply it by our second phrase here, our second monomial in this phrase, x plus 9. What is x times a plus 9? Well, it's plus 9x. Now we go to our second term here, our 4. We take this 4 times our first term there, x. What is 4 times x? That's a positive 4x. It's a plus 4x. Then we take this second term and we multiply it by our second term here. What's 4 times 9? Well, 4 times 9 is 36. So what we've got going on here is when we multiply this out using our distributive property, we see that we get 4 terms. Why? Well, we started off with 2 terms in each of these, and if you multiply each term here by each of the other 2, you're going to end up getting 4 terms altogether. Well, how many of our terms that we multiplied here gave us an answer of x to the second? How many different terms are there that have x to the second in it? Well, just 1 term. How many terms have just a constant all by itself with no variable as part of it? Well, we have 1 here. That's our 36. But if we take a look, we have 2 different terms that have an x to the first in it. We have a 9x here and a 13x here. To simplify this, we need to combine our monomials that have the same degree. Well, we only have 1 x to the second, so there's nothing to combine it with. That takes care of that. We have a 9x plus a 4x. Well, that's a 13x. Both of these have the degree of x to the first, so we can now combine them by simply adding our coefficients. 9 plus 4 is 13. So 9x plus 4x here would be a 13x. That takes care of those 2. And then our 36 gets tacked on here at the end. So by using the distributive property, parentheses x plus 4 times parentheses x plus 9 is x squared plus 13x plus 36. This here is our polynomial. And what happens with many of the factorings that you're going to see from this point forward is they are giving you a polynomial like this, and they're wanting you to work backwards to find out what are the things, what is the factorization of this polynomial. The factorization will take you back to what we have here to start with, and in this case it was x plus 4 times x plus 9. Factoring is the process of starting off with a polynomial like this and working backwards to find your original factors that you multiply together to get you this. So then, here is a polynomial, x squared plus 3x minus 18. Our question here is, what is it that's going to be multiplied together to give it x squared plus 3x plus 18? Well, we're going to back up here a screen, and we're going to take a look at what happened. Remember here, we had one term that was x squared. We had one term that was a constant, 36, but we had two terms that had an x in it. We had a 9x and a 4x. And that came as a result of this 4 being multiplied by this x, and then this 9 being multiplied by this x. But very simply, there was only one way for us to come up with our x squared. Now remember, in factoring here, we're taking this polynomial and we're seeing if we can break it down into two smaller polynomials of a lesser degree. Well, using our distributive property, x times what is going to give us x squared? Well, there's only one possibility there. It's going to be an x. We know that we have to have an x in our first term here, and we know that we have to have an x in our second term here, so that when we multiply those two together, that's going to give us our x squared over here. Now, what we want to take a look at next, we started off with our variable to our second degree, our x squared, and we now put in our x in our first term and another x in our second term. What we want to take a look at next is our last term, our constant. In our constant here, we have a constant of minus 18. And what we want to figure out are different factors that multiply together to give us 18. Because we're going to have to use some trial and error here to put those in here to see which ones work and which ones don't. At this point, it would be helpful to list what our different factors are for 18. And I'm just going to write them here. 1, 2, 3, 4 is not, 5 is not, 6 is, 9 is, and 18 is. So what we want to do is choose two factors that we can put in here and see that if we multiply it out, if it's going to give us what we're after. Well, it's a slight thing we have to be careful of here. We have a minus 18. So remember, in order to get a negative, when you're multiplying two things together, one of them has to be a negative and the other has to be a positive. So we know that one of these has to be x minus something, and we know that this other one has to be x plus something. Well, let's try 1 and 18. Because remember, this x times this x is going to give us our x squared, but to get our constant here, we're going to be multiplying our constant here times this constant here. What is a minus 1 times a positive 18? Well, it's a negative 18. Well, these are possibilities, but if we were to use our distributive property and calculate this all the way out, let's see what we get. Well, x times x is x squared. X times 18 is plus 18x. Now we come to our second term here, and we multiply it by each of our terms over here. What's a minus 1 times an x? Well, it's a minus x. And then what's a minus 1 times a positive 18? It's a minus 18. If we combine like terms here, what is 18x minus x? Well, that's 17x. We would then have x squared plus 17x minus 18. But is that what we started with over here at the top left? No, what we started with was x squared plus 3x minus 18. And what we have down here is x squared plus 17x minus 18. So we do not have a match here. So I'm going to go ahead and get rid of that. Minus 1 and plus 18 is not going to work. Well, let's say instead we choose to put a minus 18 and a plus 1. Is that going to change anything? Let's stick that minus 18 in there and a plus 1. Well, our x times x, that's still going to be our x squared. We get a match there. And our minus 18 times a positive 1 is going to be a minus 18. We have a match there, but it's still crucial what we get for our middle term. What's our minus 18 times a positive, or times x going to be? Well, that's going to be minus 18x. And then what's our positive 1 times x going to be? That's going to be a plus x, plus 1x. What is minus 18x plus x? Well, it's minus 17x. Is that what we're after? No, we're after a plus 3x. So what we have found out is that 18 and 1 do not work. And it doesn't matter whether the 18 is negative or whether the minus or the 1's negative. Either way, neither of those two work. So what I'm going to go ahead and do here is erase that 18 and that 1. And we know that 18 and 1 are not going to work. But we still have some other factors of 18 that might work. Let's take a look here at the 2 and the 9, because 2 times 9 is 18. If we go ahead and stick a 2 here and a 9 here. Remember, this is trial and error, but this is just the way it is. There's no real shortcut here. You'll get better with it with some practice, and you'll start recognizing so that you don't have to go through each of these steps or each of these trials and errors. But the trial and error is a very important thing to understand. It actually helps you to understand it better, so that's why I'm taking you through the long process here. Okay, we've stuck in now our 2 and a 9. X times x is going to be our x squared. That's a match. Our minus 2 times a positive 9 is a minus 18. That's a match. We still got to take a look at our middle terms. Minus 2 times x is minus 2x. And then 9, positive 9 times x is a plus 9x. Minus 2x plus 9x is 7x. Is that what we have over here? Nope. What we have over here is a positive 3x. So minus 2 and plus 9 will not work. However, what if we were to try minus 9 and plus 2? Just reverse these two around. Minus 9 and plus 2. Once again, our x squared will match. Our minus 9 times a positive 2 minus 18 will match. It's our middle that we're concerned about. Our middle term, minus 9 times x is minus 9x. And 2 times x is plus 2x. Minus 9x plus 2x is minus 7x. That's still not what we're after. We're after the minus 3x there. So then, minus 9 and plus 2 or minus 2 and plus 9 do not work. So no combination of 9 and 2 works. So we go erase those down here. What's that leave us with? That leaves us with 3 and 6. Let's go ahead and stick a 6 here and a 3 here. Multiplied using distributive property. X times x is x squared. That takes care of that. Our plus 3 times minus 6 is minus 18. That takes care of that. Now we got to take care of our middle term. What's a minus 6 times an x? It's a minus 6x. And our plus 3 times our x is a plus 3x. Get rid of that little dot there. So if we combine minus 6x and 3x, what's that give us? It gives us a minus 3x. Is that minus 3x what we're after? No, we're after a plus 3x. So we'll come down here and take rid of this. Does that mean we're stumped? Are we at an impasse? No. What we need to now flip around is the 3 and the 6. We need to make this positive 3 over here and make it a negative 3, and we'll make this negative 6 a positive 6. Let's see what that does. So we're going to come here and remove the minus 6, and we're going to make a minus 3 out of it. And then we're going to make a positive 6 over here. X times x is our x squared. Our minus 3 times plus 6 is our minus 18. Now let's take a look at our middle term. Minus 3 times x is minus 3x, and 6 times x is plus 6x. What is 6x minus 3x? It's 3x. Is that what we were after to start with? Yes, it is. This is our answer, x minus 3 times x plus 6. And if it would help you to see it all written out, normally I'll go ahead and do that here for you. Let's start at the beginning. X times x, x squared. X times plus 6 is a plus 6x. That takes care of our first term. Distributive property now for our second term. What's a minus 3 times x? It's a minus 3x. And a minus 3 times a positive 6 is a minus 18. We combine like terms. There's only one x squared term, so we rewrite that. We have two x terms, x to the first terms, so 6x minus 3x is a plus 3x. And that takes care of those two terms. We can cross those out, and then that leaves us with minus 18 as our last term. That matches what we started with. Okay, this next one will not take as long. It's going to be shorter here for us. Let's go through the process once again. We have an x squared. So remember, we want to have an x here in our first term, and our x here in our second term as well, our second polynomial. There's our x times x. That's going to give us our x squared. So we took a look at our first term, x times x there. Let's take a look at our second one, 21. 18, as we saw up here, had a lot of factors, but 21 doesn't. Other than 1 and 21, what are the only factors we have for 21? 7 and 3. So we're going to have a 7 here and a 3 here. But what we do not yet know is whether this is going to be a plus 3, a minus 3, or whether this is going to be a plus 7 or a minus 7. Well, let's take a look. We have a clue. We know that this has to be, our constant here has to be a positive 21. So we know that this 7 times the 3 is going to have to give us a positive 21. So then do we just go ahead and put a plus sign in here? Make it a plus 7? Let's go ahead and multiply out and see what we get. X times x is x squared. X times 3 is 3x. Now to our second term, 7 times x is 7x. And 7 times 3 is 21. And if we combine that together, what we get here, 3x plus 7x is 10x. Is that what we have over here? No, we have a minus 10x over here. So we stumped? No. Our prerequisite is that we got to get a positive 21 out of this. But if you remember, a negative times a negative is also a positive. So instead of putting a plus sign here, and because I made a red mark there, I'm going to go ahead and erase that and just stick our x back in there. Instead of this time, we're going to put a minus there. Now let's just do this final part in our head. What's x times x? X squared. What's a minus 7 times a minus 3? That's a minus 21. So that takes care of both of those terms. Now let's take this times the x. What's minus 7 times x? Well, it's minus 7x. And then what's our minus 3 times our x here? It's a minus 3x. What's a minus 7x minus a 3, or plus a minus 3x? Well, it's a minus 10x. That calculates or multiplies out. Once again, x times x, rewritten in the long term here, is x squared. X times a minus 3 is a minus 3x. Minus 7 times x is a minus 7x. Minus 7 times a minus 3 is plus 21. And your minus 3x and minus 7x here combine to make a minus 10x. And when you erase this, what we are now left with is x squared minus 10x plus 21, which is in fact what we started with. Okay, Just lastly, as a review, factoring can often require some trial and error to figure out the solution. It takes practice to get good at this. Don't get frustrated. The trial and error, oftentimes there's no other way around it, but it is an important skill to learn within algebra. That finishes up session 67 on factoring second degree polynomials.